The first example of change of interval, our statement is obtain the Fourier series for the given function, and function is expanded in terms of discontinuous function. Like we have first range is from 0 to 1, the value of the function is pi x, and second range is from 1 to 2, and the value of the function is pi into 2 minus x. Firstly, we are talking about change of interval. Change of interval takes two types of limits. One is from minus L to L and another is from 0 to 2L. Firstly, after comparing with the general value, we need to find the value of L. Now, in case of discontinuous function, how we will find L? We will check the starting point of the limit and the ending point of the limit. See, our total range is from 0 to 2. Our total range is from 0 to 2, which is divided into two parts. One is from 0 to 1 and another is from 1 to 2. That means this is our total range, the starting point and the end point. That means our total range is 0 to 2. Now we can compare it with this 0 to 2L. We can write down it as 0, 2 into 1. Now compare it with 0 to 2L. After comparing, you will get the value of L as equal to 1. Right? So whenever the starting point is 0, you will compare with 0 to 2L. But if we have the range as minus 2 to plus 2, minus of something to plus of that same thing, then we will compare that with minus L to plus L. Right? Now in our sum, we have the total limit as 0 to 2, which is further divided into two parts. So after comparing, we get the value of L is equal to 1. So that I'm going to write down L is equal to 1 in our equation. Now we need to find all the three values, A naught, AN and BN. So let us start with the value of A naught, that is given by 1 by L, 0 to L, 0 to 2L rather, right? Then fx dx. Now this is further equal to, putting L equal to 1, you will get 1 by 1 as 1. Then 0 to 2 into 1 to fx dx. Now 0 to 2 is divided into two parts since we are given a discontinuous function. So how we will break? First limit is from 0 to 1 and the value of function is pi x with respect to x. And second range is from 1 to 2 and value of the function is pi into 2 minus x dx. Now let's integrate. Pi will remain same. Integration of x is x square by 2 and the limit is from 0 to 1. In the same way, pi will remain same since it is a constant and that is in multiplication. Now integration of 2 will be 2x minus integration of x is x square by 2 and here the limit is from 1 to 2. So this is further equal to substituting upper limit 1 square 1, that means 1 by 2 minus 0. Again pi as it is here. When you will put x equal to 2, 2 into 2 will be 4 minus 4 square by 2. This will be 2. Then before lower limit you have to put one negative sign. 2 into 1, 2. That means minus 2 and second will be positive plus 1 square 1 by 2. Now 2 into 4, 4 and 4 will be cancelled out. Right? That means what will be our combined value? We can take pi common from both the brackets. So taking pi common, inside the bracket we have 1 by 2, this one 1 by 2 minus 0 is 1 by 2. Then here we have again 1 by 2. So 1 by 2 plus 1 by 2, 2 by 2, that means 1. So value of A naught is equal to 5. Right? Since we were given a discontinuous function ranging from 0 to 2, firstly, we compare the value of L by comparing it with 0 to 2L. We got L equal to 1. When we apply the complete formula 0 to 2L, putting L equal to 1, we get 0 to 2. Now, because of this continuous function, we will break the given function into two parts. Firstly from 0 to 1 and then from 1 to 2. From 0 to 1, the value of the function is pi x and similarly the second value of the function is pi into 2 minus x. So after integrating, you will get the value of A naught as 5. Next, we need to find the value of AN. So let us start with that. Firstly, let's write down the formula 1 by L, 0 to 2L, fx into cos n pi x by n dx. We got it down in the definition that here, instead of writing cos nx, we will write cos n pi x by n. N means whenever we have some constant limit, then we will use this result. Now we know that L is equal to 1. So let's substitute L equal to 1. You will get 0 to 2 fx multiply by cos n pi x dx. Now let's break the given function 0 to 1. What is the value of the function? It is pi x multiply by cos n pi x dx. And similarly, second range is from 1 to 2 and value of the function is pi into 2 minus x. Multiply it with cos n pi x dx. Right? Now we can take pi common, throughout the bracket, and let's start with our integration. Cos function, second function. Similarly, 2 minus x cos function, cos is your second function. Let's start the cos integration. Cos function same, integration of second, integration of cos is sine n pi x upon coefficient of x which is pi, then alternate sign minus derivative of x is 1 and integration of sine is minus cos n pi x upon n square pi square. Curly bracket close and limit is from 0 to 1. Right? Now let us start with second integration. Function is 2 minus x. 2 minus x as it is. Integration of cos is sine n pi x upon n pi. Then minus derivative of 2 minus x is minus 1. And integration of sine is minus cos n pi x upon n square pi square. And here limit is from 1 to 2. Square bracket close. Now this is further equal to pi as it is. Firstly, let's substitute upper limit over here in the first half of the integration by putting x equal to 1. See, when you will put x equal to 1 here, x equal to 1, you will get sine n pi, and sine n pi is equal to 0. Right? Next term, minus into minus, plus, again putting x equal to 1, you will get cos n pi. And what is the value of cos n pi? It is minus 1 raised to the power n divided by n square pi square. Upper limit done. Then let's come to the lower limit, which is 0. Come over here. 0 into anything will be 0. Third term, let's come over here. Put x equal to 0. Cos 0. N pi into 0 is 0. And cos 0 is 1. 1 upon n square pi square. And how many negatives are there? 2 are already there. And 1 negative before putting the lower limit. 3 negatives, total is negative. Done. First half is complete. Now let's come to second half. Put upper limit which is 2. 2 minus 2. 0. 0 into anything is 0. Done. Come here. Negative 1, 2 and 3. Total is negative. We have to put x equal to 2. That means cos 2 and pi. 2 pi means even multiple and cos 2 and pi is always equal to plus 1. Cos 2 into anything is even. So 1 upon n square pi square. Right? Let's come to the lower limit, which is 1. Come over here. Sine n pi into 1. That means sine n pi. That is 0. Come over here. Cos n pi. What is cos n pi? Minus 1 raised to the power n divided by n square pi square. How many negatives are there? 1, 2, 3 and 1 before putting the lower limit. So 4 negatives are there. Total will be plus. So this is equal to pi is already common. And see, n square pi square is there in all the denominators. So we can take it out. Pi upon n square pi square. Inside the bracket, see, this term and this term, both are positive. It will get twice. Similarly, minus 1 and minus 1 will be minus 2, again twice. So you can write down that twice outside the bracket. And inside the bracket, we are left with minus 1 raised to the power n minus 1. So this is the required value of a. Right? Now, whenever in the solution we have minus 1 power n minus 1, we have to make the cases of even and odd function. Now, how we can make the cases of even and odd? See, we can write down it as when n is even. An. Let's write down two cases, n even and n odd. Let's see. N even, minus 1 even power. Minus 1 with even power is always equal to plus 1. Okay, whether it is 2, 4, 6, 8, any value you can take. We are not supposed to write down a particular value. We are talking about the general value. N even, bar is even. So this is plus 1 and minus 1. Total will be 0. That means A2, A4, A6, A8, all the values will be 0. Now let's come to the odd one. Minus 1 raised to the power odd power. That is equal to minus 1, right? So minus 1, minus 2 into this 2. That means minus 4 upon 1 pi can be cancelled out and we get n square pi. So this is for the odd value. If you will put n equal to 1, you will get the value of a1. Similarly, a3, a5, a7 and so on up to. Whereas all the even values are 0 for a2, a4, a6 and so on up to. Now we have to find the value of bn also. So let us start with that. Bn, that is given by, firstly let's write down the formula again. 1 by L, 0 to 2L fx into sine n pi x upon L dx, right? Now we have L equal to 1, so you will get 0 to 2 fx as it is and sine n pi x dx. Let's split the function into two parts. One is from 0 to 1 and the function is pi x into sine n pi x dx, and second is from 1 to 2 and function is pi into 2 minus x sine n pi x dx, n pi x dx, right? Now let's integrate. This is equal to, we can take pi common. Let's start with our integration. First term same, integration of second. Integration of sine is minus cos upon n pi and minus derivative of x is 1 and integration of minus cos is minus sine n pi x upon n square pi square. Bracket close. So this is for our first integration. So curly bracket close and limit is from 0 to 1. Now let's come to the second one. Function is 2 by minus x. 2 minus x. Function same. Integration of sine is minus cos n pi x upon n pi. Then minus derivative of 2 minus x is minus 1 and integration of minus cos is minus sine n pi x upon n square pi square. Further derivative of 1 will be equal to 0. So that's why we will stop here and limit is from 1 to 2, bracket close. Now let's come to the limits. Pi outside term will remain same. Start with your square bracket. Firstly, let's come over here. See, upper limit is 1. Come over here. X equal to 1. Negative sign as it is. X equal to 1. Cos n pi. Cos n pi is minus 1 raised to the power n upon n pi. This minus is separate and this is inside with minus 1 power n. Let's come to next term. Put x equal to 1. Sin n pi 0. Next term is 0. Come to the lower limit, which is 0. 0 into anything will be 0. Sin 0 is 0. So we are getting only one term after substituting upper as well as lower limit. So let's come to next second half. Putting x equal to 2. Come over here. 2 minus 2, 0. Right? Come over here. Sine 2 and pi. 2 means even multiple. And sine all the multiples of pi are 0. Sine 2, pi 4, pi 6, pi 8, pi all are 0. Right? Let's come to the lower limit which is equal to 1. Come over here. 2 minus 1. 1. Put x equal to 1. Cos n pi. Minus 1 raised to the power n upon n pi. Now how many negatives are there? One negative this and one before lower limit. Minus minus total is plus. Right? Then come over here. Put x equal to 1. Sin n pi is 0. Right? Now see, these both terms are of opposite signs. One is negative and one is positive. So both will be cancelled out and that means the value of Bn is equal to 0. Right? We got A naught, we got An and all the Bn's are 0. Write down. So let's make our Fourier series. This implies Fourier series for the given function Fourier series for the given function is given by a naught by 2 plus summation a n cos n pi x by n plus summation b n sin n by x by n. This is for the all values of n, right? So a naught was equal to pi, so function is pi by 2 plus summation. Now a n exists for the odd values only. So let's write down over here n equal to 1, 3, 5 and so on up to. Either you can write down n is odd or you can give particular names n equal to 1, 3, 5 and the value of a n was minus 4 upon n square pi, right? Multiply it with cos n pi x only. Why? Because L was equal to 1, right? And further, n equal to 0. So that is the end. That means if x is equal to pi by 2, what we can take common? We can take minus 4 upon pi common because these terms are not containing n. Summation is applied on n only. So minus 4 by pi, summation n is odd and cos n pi x upon n square. This is the required Fourier series of given function, right? In the same way, we can continue. We can expand it in the expanded form, or you can write down in the form of summation itself.